Exothermic reaction. What's going on here? We're going to be analyzing this right here. You have 2 moles of H2O2 yields 2 moles of water plus oxygen gas, O2, diatomic molecule. In this reaction, you have obviously the y-axis is potential energy in kilojoules. The x-axis is the rate of reaction. So here we go. We have the reactants, first part of the reaction, reactants, yields the product. There's my product. We should know that. Reactant to product. Forward reaction. We have potential energy of the reactants. Top of the reactants to the bottom. We have potential energy of the products. Top of the product to the bottom. We have activation energy is the energy needed to start the reaction. There it is. Activated complex. If you jump on this roller coaster, it gets complex at the top, then it falls back down. Complex, the top of the peak, all the way to the bottom. The heat of the reaction, the change or the difference between reactant and the product. So let's go ahead and perform this reaction. So here we go. First things first, I'm going to put some safety goggles on. Get back to class, we do some labs, we open up a little bit more. We'll definitely do more of these demonstrations or labs. You'll be required to wear lab goggles. Here we go. A little bit big on me. So here we go. Going through this reaction, what I'm going to do here, I'm going to take this graduated cylinder. It's a 100 milliliter graduated cylinder. And I'm going to add 20 milliliters of hydrogen peroxide. So this hydrogen peroxide is a little bit different than the hydrogen peroxide that I use at my house. Remember I had like a brown bottle, it was 99 cents. We looked at that for solutions. This bottle is like a little bit more expandable, contractible, like an organ style bottle. And why is it like that? Because when the hydrogen peroxide heats up or cools down, it's going to start to expand or contract. So there's a little bit more flexibility in this bottle. I'm going to take 20 milliliters of hydrogen peroxide, H2O2. It says on here it's 30% of the solution. What's that mean? 30% is hydrogen peroxide. The other 70% is going to be water. So I'm going to take 20 milliliters, roughly 20 milliliters. So this hydrogen peroxide you cannot buy at Walmart. You can't buy it at the drugstore. If you go to a hair and beauty place, I haven't been there much. If you go to a hair and beauty place, you could probably find a higher concentration of this volume. Why? Because they use the hydrogen peroxide for hair coloring. All right, so I added a little bit more. I added 22 milliliters. So when you take a reading, what you want to do, you want to pour it, and you want to get low, get low, get low, get low, get low to the flow. You want to look down at the meniscus just to check that curved line is going to be equal. So you want to make sure that meniscus is at the right level. Next up, I'm going to drop a drop of food coloring, red. Right now, nothing crazy is going on. You have a heterogeneous mixture. Next up, I'm going to add some soap. So right now, hydrogen peroxide, food dye. Now I'm going to add some soap into the solution. So all it is dish soap. I'm adding about 10 milliliters of the dish soap. Once I pour this in, you'll see that it's starting to turn into a homogeneous mixture. It's like starting to stir. It's mixing a little bit more. And the last thing that I have to add, so the last thing I need, which is not in this equation, this is going to be my catalyst. This is going to make the reaction happen at a quicker rate. So this catalyst is sodium iodide. What's the catalyst do? It speeds up the rate of reaction because it's lowering 2 intervals. It's lowering my activation energy. It's lowering my activated complex. So the last thing I'm going to add is the solution of sodium iodide. It's a 2 molar solution of sodium iodide. I'm going to add 5 milliliters to the small graduated cylinder. So I rest my fingers on the bottom just so it doesn't tip over. You don't want to get it on you. Obviously, you don't want chemicals to land on your body, your flesh. Once you get a little closer to the volume you You want to get low and check it on out. Make sure you're at the meniscus. We did this in the beginning of the year. We measured out volumes in the beginning of the year. You know how to accurately record a volume. Hopefully you can measure as well. All right, so the last thing I'm gonna do is I'm gonna add this catalyst to this larger graduated cylinder. We'll have a reaction start to form. So once I pour this in, the amount of collisions, the effective collision is going to increase immensely. So what's gonna happen, as I pour this in, these particles are gonna start to collide, have more effective collisions. They're gonna be oriented correctly. There's gonna be more energy in the system as well. So it's gonna have a ton of these little effective collisions going on here to proceed to the product. So here we go. Last part of the reaction. Let me move you guys on closer for a second. Okay, last part of the reaction. Here we go. Starting to happen. Here we go. Maybe you can see that there is some heat being generated here. So heat is definitely given off in this reaction. You can see that happening. It's exploding here. You see this reaction here? You have in this, you can figure out it's going to be water and it's going to be oxygen gas released in this situation. Those are the products of this reaction. The presence of heat in the situation, you can't really see it as much now, but it is definitely warm if you bring your hands closer to it. That presence of heat was being released in that situation. You could see it's going to be an exothermic reaction.